Hello viewers, welcome to today's lecture on data link control. In the last lecture, we have discussed about flow and error control, two important mechanisms used for efficient and reliable data communication. In this lecture, we shall discuss about other components that is required for data communication between two machines or two systems. Actually, a higher level of logic has to be added above the physical layer to facilitate efficient and reliable data communication. That is the topic of today's lecture. Here is the outline of the lecture. First, we shall discuss about what is data link control. Then we shall discuss the key components of data link control such as frame synchronization, flow control, error control and link management. We have already discussed about flow control and error control in details. So, we shall not discuss about these two important components in this lecture. However, we shall see how they are used here in some standard protocol. Then we shall consider about link management, and we shall discuss about an important standard that is known as high level data link control or HDLC in short. Particularly, it is characterized by three important parameters like types of stations, data transfer modes, frame format. All these things we shall discuss in detail. On completion of this lecture, the students will be able to explain the function of data link control. They will be able to specify various data link control functions. They will be able to explain how high level data link control works, that is HDLC works, which is the most popular data link control protocol that is in use today. Explain how piggybacking is done in HDLC, and also they will be able to explain how data transparency is maintained in HDLC. So, before we discuss about the definition of data link control, let us look at the key features of the link that is being used for communication between two machines. First feature is, we shall assume that two machines are directly connected. That means they are not connected through some intermediate node or other machine. We shall assume that two machines are directly connected. Second assumption is, there will be occasional errors in the communication circuit. So, there will be possibility of some errors in the communication circuit as data communication take place. There will be some errors, but obviously the probability of error is quite small, and as a result it will occur occasionally, not frequently. Third important assumption is, there is non-zero propagation delay. As I mentioned in the earlier discussion in the last lecture, there will be some propagation delay for data communication. It will take some time, and obviously this delay will be dependent on the transmission media used, and also it will be dependent on the distance between the two machines. That means the transmission media and also the distance between the two will decide the propagation delay. Then the communication link and the machines have finite data rate. So, the communication will take place with some finite data rate, because the machines will have limited processing capability, and based on the bandwidth of the medium, the data rate will be limited. So, it is limited both by machines and also by the communication link. Obviously, in this scenario, our objective is to devise suitable mechanism for efficient and reliable communication. Obviously, by using the unreliable transmission link that we are using. And this will require great deal of coordination between two machines, and this coordination is represented by this data link control protocol. So, a data link control is nothing but a layer of logic added above the physical interface to achieve the necessary control and management. As you can, as it is shown here, here you have got two machines, two computers. They are connected by a communication link or data link. It can be twisted pair, it can be optical fiber, it can be coaxial cable, it can be wireless, whatever it may be, they are linked, directly linked. And this data link is the transmission medium between the systems, which when a data control protocol is used is known as data link. So, this is the data link. So, you can use varieties of medium, but it is the protocol that we are discussing is really independent of the medium that you are using. So, this is irrespective of the medium that you are using for linking to devices. We are mainly concerned with the layer of logic or what we call protocol that has to be used for efficient and reliable communication. What are the key components of the data link control? These are listed here. First one is frame synchronization. You see, we have already discussed about some kind of synchronization that is necessary for data communication between two links, particularly in the control context of asynchronous and synchronous serial communication. Now, the synchronization can be done at three different levels: bit level, word level and frame level. Here we are concerned with frame communication. We are interested in sending a frame of information, a sequence of bits or a sequence of characters, and obviously the beginning and end of a data block which is called frame should be distinguishable, so that the receiving end can identify where a particular frame is beginning and when it is ending. So, that is known as frame synchronization. So, this is in addition to bit and word synchronization. This will work at a little higher level. Second is flow control. We have already discussed about it in detail, and the basic objective is the sender should not send frames at a faster rate such that the receiver is well overwhelmed. We have already discussed various flow control mechanisms such as stop and wait flow control, and also the sliding window flow control. And we shall see here in most of the applications, sliding window flow control is used for its efficiency, better efficiency. Then error control techniques we have already discussed. This is necessary because any bit errors introduced by the transmission system should be corrected, and we have already discussed the error control techniques such as stop and wait ARQ, go back and ARQ, and selective repeat ARQ. These are used in this protocol. These are included in this data link control protocols. Then the control and data on the same link, as we have discussed, as I have mentioned, that you have to send data and also you have to perform the management. So, the receiver must be able to distinguish between control information and data that is being sent using the same medium. So, you are sending that control and data through the same link, and unless there is some kind of protocol, that means agreed upon rules and conventions, then it is not possible to identify what is data and what is control information. So, that has to be established, I mean that has to be used so that the receiver can identify what is control information, what is data being transmitted. Then comes the link management. This is necessary so that the procedures for management of initiation, maintenance and termination of a sustained data exchange. That means, say two machines are connected, and you have to first set up the connection, then you have to maintain the connection throughout the period for data communication, and also when the data transfer is over, then it has to be terminated. All these things is part of this link management. So these are the key components of data link control. We shall discuss how actually they work. First, let us focus on frame synchronization. So when data transferred from the transmitter to the receiver, unless steps are taken to provide synchronization, the receiver may start interpreting the data erroneously. So some kind of agreed upon convention has to be used, and as I mentioned, synchronization levels are done at 3 different levels: beat, character, and frame. And the two common approaches are asynchronous transmission and synchronous transmission. So let us consider these two one after the other. First, let us consider asynchronous transmission. So in asynchronous transmission, the synchronization is done at the character level. So data transmitted one character at a time. As we know, the number of bits that can be used can vary from 5 to 8, and timing or synchronization must only be maintained within each character. We have already seen, we have already discussed about this. With the help of a start character, the synchronization is achieved, and with the help of this start character, the synchronization is done, and this signifies the beginning of a character, and after that there can be data bits which can vary from 5 to 8, and there is an optional, this is an optional parity bit. If error detection is required, parity bit is used, then it is followed by stop bit, and so the synchronization is restricted within this character, and which is done with the help of start and stop bits. And then immediately after the stop bit, either another start bit can start, in that case it will become 1, or it can remain 0. Actually this is 1, this is 0. It will remain 1 if it is not a if no new character is sent, or it will become 0. That means a start character will start, will start if another character is being sent. So in this way, character by character synchronization is done in asynchronous transmission. And here, as you can see, the receiver has the opportunity to resynchronize at the beginning of each new character. So because synchronization is done at the beginning of each character, the clock frequency between transmitter, as I have already discussed in detail, the clock frequency between the transmitter and receiver need not be exactly same. There can be a difference of about 5%. So that kind of flexibility exists here. So when no character is being transmitted, the line between the transmitter and receiver is in idle state. So this is the idle state, one state. So a character can be sent, then the line can remain idle, then another character can be sent, which is synchronized. We have already seen that the asynchronous transmission require 20% or more overhead. So asynchronous transmission is, although very simple and some kind of self synchronizing, it is not very efficient because of high overhead. Now asynchronous protocols are to be developed on top of the character oriented transmission, and so this has been primarily used in modems, and particularly whenever you want to send a file from one machine to another machine, this type of asynchronous protocols are to be used. Some of the example protocols are known as X modem, Y modem, Z modem, and so on. So the character format is briefly specified here. It has got 1 byte start of header. So you have got a character which is start of header, SOH, start of header, and it is followed by 2 bytes of header. So this is 2 bytes of header. You have got 2 bytes of header. However, 1 byte gives you the sequence number. So 1 byte is a sequence number, and the other byte, actually the complement of that, is being sent here. so that using these 2 bytes the sequence number and its complement is received. So, if there is any error, that can be detected with the help of this bit, with the help of these 2 bits. So, second byte is essentially to check the validity of the sequence number. So, whatever character is sent, thus the complement of this is sent here. Since we are using a 1 byte of character, the number of stations that can have is 128. So, address is restricted to 128, and after that there is 128 data field, fixed data field. So, it is restricted to 128, and after that 128 data field there is a checksum or CRC that is only of 1 character, that means 8 bit. So, this is the frame format, and here you have got the 128 data and finally the character. This is how you can send one file or one frame. You can see there is a character sent which is start of header, it is followed by 2 bytes, then 128 byte fixed characters and CRC, and in between one character there can be a gap. So, as we have seen, this gap can be variable between 2 characters. The variable gap is provided. So, this is how the X modem works, and Y modem, Z modem are essentially some extensions over X modem. I am not discussing it in detail. So, there are several such protocol. So, this asynchronous protocol I have briefly discussed here. However, the asynchronous protocols are not very widely used because of the inefficiency or high overhead, and that is why the synchronous transmission is commonly used. And in synchronous transmission, a block of bits or characters is transmitted in a steady stream without start and stop bits. So, without start and stop bits, a stream of characters or bits, it can be both, are sent one after the other without start bit and overhead, and the block may be arbitrarily long. So, although the block may be arbitrarily long, but to prevent timing dip between transmitter and receiver, clock signal, okay. So, arbitrarily long, but as we know, if a frame is arbitrarily long, the probability of error increases. That is why the length is not really very long, it is restricted to some upper limit. Moreover, to prevent timing dip between transmitter and receiver, clock signal is embedded in the data signal. For example, by using Manchester encoding, and clock is resonated at the receiving end. As we have mentioned earlier, the clock cannot be separately sent whenever 2 machines are located wide apart, but for synchronous transmission it is necessary that these 2 clocks should be identical. How that can be achieved? One way of doing it, that we embed the clock as part of the data signal by suitable encoding. Manchester encoding, one such encoding technique, where we have seen for each bit one transition is included, which helps in regenerating the clock at the receiving end with the help of some special hardware such as phase lock loop or PLL. So, phase lock loop can be used to regenerate the clock at the receiving end, and for that purpose some encoding is used. Other encodings can also be used. Manchester encoding is one of the popular ones. Now, for sizable blocks of data, synchronous transmission is far more efficient than asynchronous mode. As we have already mentioned, that the asynchronous communication transmission requires 20% or more overhead, and obviously this is not acceptable whenever we are sending over a long distance or you want a higher efficiency. In such a case, synchronous transmission gives you very high efficiency. It can be, that efficiency can be even 0.001% or maybe 0.01%, which is that means the overhead is very small, 0.01% or 0.001%. So, with such a low overhead, the synchronous transmission gives you much better efficiency. Now, let us look at the protocols that is being used in synchronous transmission. There is that there is another level of synchronization required so as to allow the receiver to determine the beginning and end of block of data. That means apart from synchronization of the clock, there is a need for synchronization for identifying the beginning and end of a block of data. And there are several protocols which can be broadly divided into two types: character oriented and bit oriented. Character oriented, example of a character oriented protocol is binary synchronous communication, or BSC, binary synchronous communication, which is based on characters. So a sequence of characters are sent one after the other. Obviously there will be some sync character followed by, there will be a frame involving sync character, then a sequence of characters, then CRC, another thing. So the BSC is one such example, but the character oriented protocols are not very popular because you cannot really pack more information in character oriented protocols. On the other hand, the bit oriented protocols allows you to provide more information, to pack more information, and as a result bit oriented protocols are very popular. And in both cases, every block begins with a preamble bit pattern and generally ends with a postamble bit pattern. So this is the typical framing that is being done, and a typical synchronous frame format is given here, which shows that it will have some kind of flag, 8-bit flag. So 8-bit flag followed by some control bit. So flag, control, then there can be data bits, then the control field. So it can be data, again some control fields, and another this control field can be for error detection, and again the flag. This is the typical format that is being used in synchronous frame format. And as you can see, the beginning and end is identified with the help of a special flag. It can be 8-bit flag. So the control information, preamble and postamble in synchronous transmission are typically less than 100 bits. So these are essentially the overhead. So this is restricted to less than 100 bits, and this can be thousands of bits. So since this is thousands of bits and this is restricted to only 100 bits, obviously the overhead is insignificant portion of the entire frame that is being sent. As a result, it gives you higher efficiency. Now let us focus on the most popular protocol that is being used for data link control, and this is known as high level data link control, or HDLC in short. And it is one of the most important protocol, as I mentioned, and it is the most widely used bit oriented protocol. As I mentioned, there is a possibility of having two types of protocols, character oriented and bit oriented, but character oriented protocols are not popular, so bit oriented protocols are used, and HDLC is one of them. It is also the basis for many other important data link protocols. Although HDLC has not been fully accepted in many protocols, but some subset of it or a variation of it has been included in many protocols. That's why it is the basis for many other important data link control protocols, and some of them we shall discuss in little more detail. And this particular protocol, HDLC, was adopted by ISO, International Standards Organization Committee, and also embraced by ITU-T. So as a consequence, two important standards provider accepted this protocol, and obviously this has to be very widely accepted. And some of the important characteristics are: it supports both full duplex as well as hub duplex communication, and also it can work in point to point and multi-point configuration. That means point to point means it can be connected between two machines, or you can have a number of machines connected one point, and it can be connected to other machines also, one to many, so multi-point. So it can work in both the cases, as we shall see. This HDLC is characterized by 4 important parameters: station types, configurations, response modes and frame formats. So, we shall discuss each of them one after the other in little more detail. First, let us focus on station types. There are 3 types of station. First one is known as primary station. Primary station is responsible for operation of the link. So, it acts as some kind of master, and frames issued by primary stations are called commands. That means, the primary station acts as a master when data communication takes place between 2 machines, and primary whatever is issued by the primary station is called commands. So, commands are issued by primary station. On the other hand, secondary station operates under the control of primary station, and frames issued by secondary stations are known as responses. So, commands are issued by primary station, responses are issued by secondary stations, and primary maintains a separate logical link with each secondary. That means, a separate logical link is maintained with each primary. So, primary maintains a separate logical link with each secondary. So, essentially a link is established between a primary and secondary. Now, there is a third type of station or machine which are known as combined station. So, the combined stations combines the features of primary and secondary. We have seen that primary stations can issue commands, secondary can issue responses, but whenever it is a combined station, it may issue both commands and responses. So, both can be issued by a combined station. So, we have seen the 3 types of stations that can be used in HDLC. Now, let us consider the link configurations. There are several link configurations, like unbalanced configuration is the first one. So, in the case of unbalanced configuration, as you can see, it consists of one primary and one or more secondary. So, it can be whenever you have got one primary and one secondary, it can be point to point, or whenever you have got one primary and several secondaries, then it can be multi point. So, let us see how the communication takes place. As we have already mentioned, primary issues a command, and in the multi-point configuration the command can go to both of them, and obviously one of them will respond. So, the response is coming from the intended secondary and which goes to the primary. So, this is how the unbalanced configuration works. The second link configuration is known as symmetrical configuration. In symmetrical configuration, each physical station of a link consists of 2 logical stations, one primary and one secondary. So, you see here you have got a single physical station, however, functionally it has got 2 logical stations. That means, you have got one is primary, another is secondary, and as a result here you have got a symmetrical configuration. Primary is connected to secondary, and primary on the other side is connected to the secondary of this side. So, these 2 logical stations communicate with another station which is also having 2 logical stations. So, you see you require 2 different links, and here the primary can issue comments, and that the other side secondary will issue response. Similarly, the comment can be issued by the primary of the other side, and obviously the secondary of one of this side can issue responses. This is how the communication takes place in symmetrical configuration. So, in symmetrical configuration, as you can see, you have got 2 logical stations within a single physical station, and the communication takes place in this manner. Coming to the third configuration, which is known as balanced configuration, which consists of 2 combined stations. So, here you can see here you have got one physical station and one physical stations, and both are of combined type. Since both of them are combined type, both have the capability of issuing commands as well as responses. So, you see now a command has been issued by this station which goes to the other side, and the other side will issue response in for the corresponding comment. Similarly, this side can also issue a comment, and this side will in turn will generate the response. So, you see a single combined station can issue both comments and responses, and that is how the exchange of information take place in balanced configuration. So, you see this is how the balanced configuration works using two combined stations, and here it is always point to point. And coming to the third important parameter, that is the data transfer modes. There are three data transfer modes. The three data transfer modes are normal response mode NRM, asynchronous balance mode ABM, and asynchronous response mode ARM. And in the three cases, actually the different types of the modes, the way the works is given here. First, let us consider the normal response mode NRM. This is used with balanced configuration. So, in this case, this is used with unbalanced configuration always, and in the unbalanced configuration it is used. That means there will be one primary and you can have one or more secondary. So, primary may initiate data transfer to a secondary may only transmit data in response to a comment from the primary. So, this secondary will be able to transmit data when it is polled or when it is asked to give some response. However, it can be used on multi-drop lines also. As I mentioned, there can be one primary, one and several secondaries. So, in this case, a number of terminals connected to a host computer. This is an example of multi-drop lines. So, you can have a computer, this is your say server, and then you can have a number of terminals. So, these are terminals. So, this is the situation for this normal response mode. That means, here I have shown this way, this is a logical diagram, but it will be you can use a bus sort of thing. So, the computer polls each terminal for input, and we have already discussed how the polling can be done. Also used for on point to point links, and if the link connects, so this can be used both for point to point as well as multi point, as I mentioned. If the link connects a peripheral then okay, so this is the point to point which is used, say a computer is connected to a peripheral, say this is a computer and this is a printer. So, this is essentially the master, and this is the primary, and this is the secondary in the HDLC terminology, and the communication is in the unbalanced mode. Coming to the second data transfer mode, asynchronous balanced mode. Here you have used in balanced configuration. This asynchronous balance mode can be used, as its name implies, it can be used only with balanced configuration. So, either combined stations may initiate transmission. So, here you have got two machines and both of them are combined type, and obviously in this case data transmission can be initiated by either of them, and this is possibly the most widely used technique, and it makes most efficient use of full duplex point to point link, as there are no polling overheads. We have seen in case of unbalanced mode, if it is a multi point, then polling overhead is there, but in this particular case you can have two machines connected by full duplex link. So, full duplex link, so data can go in this direction as well as in this direction. So, you can have, and there is no need for any polling, and both of them can be of combined type, combined machines. So, this is how the asynchronous balanced mode works. Third type is asynchronous response mode or ARM. This is used with an unbalanced configuration. Secondary may initiate transmission. Primary still retains the responsibility of the line. However, for example, initialization, error control, these are all done by the primary. However, in this case secondary may initiate transmission in the asynchronous response mode, which is not possible in the first mode. However, this is rarely used. and may be used in very special situations where a secondary may need to initiate transmission. Normally, all the data transfer take place with the initiation of the primary, but in this asynchronous response mode, the secondary may also initiate data transmission. So, whenever this kind of situation is required, then in that case asynchronous response mode can be used. So, coming to the fourth important parameter, that is your frame types. We have got three different frames: I frame, information frame, S frame or U frame. So, I frame, S frame and U frame. So, this is your unnamed frame. S stands for secondary frame and I stands for information frame. As you can see here, you have got flag, address, control, information, frame check sequence and then flag. This is the typical format of the I frame. However, S frame is not having information part, it is having all the other fields, the flag, address, control, frame check sequence and flag. And in case of unnamed frame or the U frame, you will find there is a flag, address, control and information part is optional, and this information is provided for management and control. So, this is not really the user data. In case of I frame, this is user data. Here it is used for management and control. Whenever some information has to be sent for management and control, it is provided here. So, you have got flag, address, control, this optional information, frame check sequence and flag. So, these are the three different types of frames possible. Let us consider each of these fields separately one after the other. First, let us consider the flag field. Each frame starts and ends with the separate bit pattern, that is your 0, 1, 1, 1, 1, 1, 0. So, you have got 6 ones and 2 zeros flanked by 2 zeros on both sides. So, 6 ones flanked by 2 zeros on both sides acts as a frame, acts as a flag, that is the which is actually the starting and ending flag. So, which signifies the start and end of a particular frame. Now, this bit pattern may appear as part of the information or may appear it as part of control. So, in such a case, what has to be used? Whenever we are sending the bit pattern 0, then 6 ones and 0, which appears as part of data, then what will happen? Then there is a possibility that if it appears in the middle of an information bits, then that can be considered as the ending flag. So, as a consequence, this will divide a single frame into 2 frames. So, this problem has to be avoided, and that is being avoided by using bit stuffing, as we shall see, so that there is data transparency to unambiguously identify flag fields. So, the flag fields should not be present in the information bits. So, to unambiguously identify the flag fields, bit stuffing is used. We shall discuss about it in more details. And as you can see here, we are using the same flags. When the same flag is used to mark both the beginning and end, there are 2 situations. A 1 bit error may merge 2 frames into 1, and 1 bit error inside the frame could split it into 2. This can happen. However, when no error occurs, there is no problem, it continues, and you are using frame check sequence for detecting errors. Now, let us consider the address field. This address field identifies the secondary station that transmitted the frame. That means, whenever a secondary station sends a frame, it gives its own address, that is known as from address. That means, whenever it is going from a secondary to a primary, then it is called from address. That means, where from it is coming, that is provided as part of this address. On the other hand, there is another situation whenever it is going from a primary to a secondary. So, this is your primary and this is your secondary. When it is going from here to here, then the address is essentially to address. So, here it is to, here it is from. So, in the same address field, you can have either two types of address, to address or frame address, depending on in which direction information transfer is taking place. Obviously, the primary, there is only one primary in the system. So, there is no need for its address to be part of the data, part of the frame. So, only the address of the secondary is needed. That is why this from address and to address approach is used. So, this field is not needed for point to point links, but is included for the sake of uniformity. Whenever it is point to point, you have got only two devices, two stations, one primary and another secondary. So, there is no need for any address, because there is only one, but when it is multi point, there are several secondaries. In such a case, address has to be used, and since it is of 1 byte, you can have at most 128 different types of secondaries. So, this address, whenever it is single octet, single octet or 1 byte, then you can have 128 addresses, but there is a provision for multi octet addressing. In such cases, obviously, the number of machines that you can have in a multi-point communication can exceed 128. So, there is provision for multi-point, multi-octet addressing, but single octet is the most commonly used one. Now, let us focus on the third field, that is the control field. This control field defines three types of frames: information frames, which can carry data to be transmitted; flow and error control information are also piggybacked using ARQ mechanism. Then supervisory frames provide ARQ mechanism when piggybacking is not used. Unnumbered frames provide supplemental link control functions, and in case of I and S frames use 3-bit sequence number, as we shall see. So, the flow and data control that is being used here will be explained here how it is being done. Let us look at the control frame format. First of all, the control frame decides what type of frame it is. For example, if the first bit, so that it is going in this direction, it is the first bit of the control flag, control field. If it is 0, then it is I frame or information frame. And as you can see, information frame has got two 3-bit numbers, NS and NR. NS is actually the sequence number of the station from which is sending the information. So, it is the sequence number of the station which is sending the information. So, it is 3-bit. So, obviously, if you use go back and ARQ, go back and flow control and ARQ, then the total number will be 7. That means 7 possible sequence number can be used. And NR is used for piggybacking. NR is essentially specifies the frame it is expecting. That means this NR tells you ACK that N, that value of N is provided here. So, how the piggybacking is done, whenever both sides are connected by using full duplex communication, I mean the two stations are connected by full duplex communication, then piggybacking can be used and acknowledgement information can be provided as part of the information frame. So, this is how these 3 bits are used for that purpose. So, you can provide ACK as well as reject and other frames as part of this. However, when you are not using there is no data to be sent by the station, that means whenever there is no data to be sent by the secondary, then it can send one S frame. So, in case of S frame you will have, as you can see, there is a code and it is decided by 1 0. So, in that S frame there is no data. So, there is no data field in the S frame. However, it has got the code, 2-bit code, then this bit flag stands for pole and final. This is used whenever you are using a secondary, say it is used in this case also, information frame also. Whenever you are sending, you have got a primary and a secondary, then whenever primary sends it, actually this can when this bit is 1, this signifies the polling. That means when it is going from the primary to the secondary. On the other hand, whenever it is coming from the secondary to the primary, it can be, if it is 0, then it is the data coming from the secondary to the primary. Whenever it is 1, that signifies it is the final frame that is coming. So, in this way, a sequence of frames can come from the secondary to the primary. So, polling is performed with the help of these bits, and the secondary can signify with the help of this code the different types of information that is being provided as part of that NR. For example, when it is, say, the code is 00, this stands for RR, that means receive ready. That means receive ready is essentially whenever the receiver is sending an acknowledgement which is provided as part of NR. So, NR is providing that acknowledgement, then it is RR, receive ready for receiving that particular frame. Say for example ACK say 6, that means 6 is provided here. So, here you have got 1, 1 and 0. So, 6 is written here, and then receive ready. So, an acknowledgement frame is being sent, or it can be say 0, 1, then it is reject. That means whenever negative acknowledgement is being sent, a particular frame has to be rejected. So, NAK, for example, it is reject, then it is 1, 1 and 0 once again. That means here in case of go back and ARQ, the frame has to be repeated from the frame number 6. So, this signifies the frame which is in error, which has to be retransmitted. That is the case whenever it is 0, 1, that is reject. So, it specifies what is the function, and the frame number is provided here, that acknowledgement number is provided here. Then it has, if it is 1, 0, then it is receive not ready, RNR, receive not ready. That means whenever the other side is not ready, then the data cannot be sent. So, you see here you can perform flow control. If the secondary is not ready, in such a situation that RNR frame can be sent, that supervisory frame can be sent by the secondary to the primary. Finally, whenever it is 1, 1, then it can be S reject, SREJ. That means whenever the selective repeat ARQ is being used, in such a case a particular frame number which is mentioned here has to be selectively repeated. That is being specified with the help of this bit. So, you see this is how the S frame with the help of this code can mention about different types of functions of that supervisory frame which is coming from the receiving side to the transmitting side. So, whenever a secondary has no data to send, piggybacking cannot be done. In such a case, this negative acknowledgement or acknowledgement can be sent in this manner. Finally, in case of U frame, again the code is there which is used in S frame and U frame, and the 3 more bits are used for coding. We are not going into the details of use frame, which are essentially used for control and management purposes. Control and management. We shall not go into the details of this 3-bit code. Now, coming to the information field, it is present only in I frames and also in some U frames, as I mentioned, and whenever it is present in iframe, it is user data that is being sent, and when it is used in uframe, it is management and control information. So, it can contain any sequence of bits, but that has to be multiple of 8, but is usually limited in length from consideration of error control. As I have mentioned, although you can send unlimited number of bits, but it is restricted so that the frame does not suffer from error. That means, if one bit gets corrupted, then a retransmission has to be done. To avoid that, it is better to restrict the length so that error does not occur, and probability of error increases with the length. As longer the length, more probable possibility of error is more. Frames with MTI field are transmitted continuously on an idle point-to-point lines in order to keep the connection alive. So, whenever a particular station has no data to send, but a particular session has started, in such a case continuously frames are sent with no information in the information field. That is also possible, particularly this is necessary to keep the connection alive, otherwise the link will be disrupted. Now, as I mentioned that your information part may contain that flag, that is your 0, 1, 1, 1, 1, 1, 1 and 0, and this should not appear in the information field. That means, information field should not contain a flag character. So, to do that, what is known as bit stuffing is used. So, bit stuffing is explained with the help of this animation. So, let us assume this is the sequence of bits to be sent, data to be sent, it is present in that information field. I have not given you the complete field, but this is part of the information field. And so, this is the data to be sent, and what is being done after occurrence of 5 consecutive ones, a 0 is forcibly introduced. So, here you can see 1, 1, 1, 1, 1. After these 5 ones, a 0 is introduced. Here also 1, 1, 1, 1, 1, 1, 0 is introduced. So, after each occurrence of 5 consecutive ones, a 0 is introduced, which is known as bit stuffing. So, here you see the flag address control, and after this a 0 bit has been introduced, and here also a 0 bit has been introduced, and so bit stuffing has taken place, and this is the frame to be sent with 2 extra zeros, and this is the frame that is being sent, and this is the frame received. At the receiving end, the receiver knows that after each 5 ones, you can see after 5 ones there is a 0. So, so these zeros are replaced to get back the data. So, the receiver will remove those redundant zeros to get back the data. So, this is how the frame is recovered at the receiving end. So, this is how the bit stuffing is done for data transparency. Finally, the frame check sequence field, which can use either 16 or 32 bit CRC code computed using the address, control and data fields for the purpose of error detection using the cyclic redundancy code. We have already discussed about it in more details. Now, as I mentioned, several protocols have been developed based on HDLC, which are known as link access procedure protocols, and LAPD and LAPB, LAPM, actually it has to be M. These are the 3 examples. This LAPB, it works in ISDN and uses asynchronous balance mode of transmission using and to connect to devices in a combined type. Link access protocol D is used in ISDN using ABM, that asynchronous balance mode. That means in both the cases, as we find, it is used for point-to-point link. Then link access procedure for modems, that is used in modems. Essentially, it is used to design synchronous to asynchronous conversion, error detection and retransmission. These functionalities are not provided in DC-DT interface. So, this is added on top of that DC-DT interface to provide the HDLC features. So, now it is time to give you the review questions. First question is, why are asynchronous protocol losing popularity? Second question is, why bit oriented protocols are gaining popularity? Third question is, in HDLC what is bit stuffing and why is it needed? Fourth question is why is piggybacking? What is piggybacking and how is it used in HDLC? Now it is time to give you the answers to the questions of lecture 16. First question was, in what situation sliding window protocol performs better than stop and wait protocol? Obviously, sliding window protocol performs significantly better than stop and wait protocol when the value of A, propagation time by transmission time, is large. This happens in long distance communication through optical fiber satellite link or when you are using very high speed communication. Second question was, consider the use of 10 kilobit size frames on a 10 megabit satellite channel with 270 millisecond delay. What is the link utilization for stop and wait ARQ technique? So, here the value of A is 270 because transmission time is 1 millisecond, propagation time is 270 millisecond. So, utilization is only 0.369%. On the other hand, when you are using go back and ARQ with window size 127, then that means you are using 8 bit for the frame number. In such a case, the value of A is 270 and obviously the utilization will be 46.86%. And if you use more number of bits, that means larger window, then it can be even 1. Finally, the fourth question was, compare the window size, number of bits used for numbering the frames and buffer size for 3 ARQ techniques. So, in stop and wait, window size is 1, buffer size requirement is 1. In go back N, receiver has got window size only 1, transmitter will have window size 2 to the power k minus 1, buffer size in transmitter is 2 to the power k minus 1 and receiver will have only 1. The selection, in case of selection reject, however, as we know, the receiver and transmitter both will have window size 2 to the power k by 2 and buffer size is also 2 to the power k by 2, both for transmitter and receiver. So, with this we come to the end of today's lecture. Thank you. Hello viewers. Welcome to today's lecture on switching techniques. So far, we have assumed that two devices or equipment are directly communicating with each other.